Okay, so for example 6, once again, there's no way that we could possibly just use transformations to find those vertical asymptotes. So we're going to have to do it algebraically again. So we'll take the denominator, and we're going to set it equal to 0. And then again, this one is quadratic, so in order to solve it, we're going to try factoring first. Now this one has a leading coefficient, so rather than just looking at the last term there, I'm going to do a little bit of scratch work on the side. So I'm going to take that 3 and that -7 and multiply them together. That gives me -21. And I'm looking for things that'll multiply to make -21 and add to make a -4. Since it's a -21, I have to have one negative, one positive. So -7 times the 3 would do what I need it to here. So that means this will factor. So I'll go ahead and set up my 2 sets of parentheses. Still equals 0 because it has to be an equation, otherwise we can't solve it. Now we focus just on that 3x squared first. So we're going to do 3x times x makes 3x squared. Then we're looking at the outside product. So 3x times whatever we put over in the space over here has to equal one of those two numbers we found in blue on the side there. So multiplying by 3, I can't make a -7, but I can make a +3. 3 times a +1 would be a +3. Then our inside product here would be 1 times something has to be the other number that we have in blue over there. So 1 times -7 would give me -7. Now that I've got it factored, I set each of those factors equal to 0. And then I can use algebra to solve them. So for that first one there, my first step would be to add 7 to both sides of the equation. That would give me 3x is equal to 7. And then 3x means 3 times x. So to undo that, I would divide by 3. And so 3x divided by 3 is x. And 7 divided by 3 is just going to be 7/3. For my other equation there, we'd have subtracting 1 from both sides using the algebra to solve it. And that would give us x is equal to -1. So again, I have 2 vertical asymptotes on this one. So I'm going to write them down in order from least to greatest. So I've got x equals -1 and x equals 7/3. And of course, I am writing that as an equation because a vertical asymptote is a line, so it requires an equation there. Okay, so that brings us to example 7 here. Now this one has a negative in front of the fraction there for the function. But that doesn't really make a difference for what we're doing here. That negative on the graph would make it reflect over the x-axis before any other transformations occur. But since we're just looking for vertical asymptotes, that's not really an important thing. We're just going to follow the same procedure. We'll set the denominator equal to 0, and then we'll solve it. Now again, this one is quadratic, and this one's a special factoring pattern. This is what we call a difference of squares. Now the difference of squares always factors into conjugate pairs. So that means it's going to be the square root of the first term plus the square root of the second term, and the square root of the first term minus the square root of the second term. Then I can take each of those factors and set them equal to 0. And then solve using algebra. So I get x equals -7 and x equals 7. So again, this one has 2 vertical asymptotes, and I'm going to list them in order from least to greatest. Okay, so now you're going to try number 8 and then answer the question on your Google form.